Dr. Raziq Yaqub is an associate professor in the Electrical Engineering and Computer Science Department, Alabama A M University, USA. So he earned a PhD in wireless communication from Keio University, Japan, and MBA in marketing from Fairleigh Dickinson University, New Jersey, USA. He is an inventor of technologies in cybersecurity, of financial technologies, wireless communication, smart grid, and connected electric vehicles. He has 34 issued patents and is a recipient of Inventor of the Year Award 2014 from the Inventors Hall of Fame, New Jersey. He received an Award of Excellence in Scholarship and Research 2019 from the President of his university, an Award of Innovator Young Faculty, an Award of Outstanding Engineer Educator from the Dean of his college, and Outstanding Engineer 2020 Award from IEEE Region 3. So he remained an Executive Director of Toshiba America Research, New Jersey, to lead 4G LTE Department Head of Nixon University, Princeton, New Jersey, to lead Cybersecurity and Director of Global R&D of TechVox Huntsville, Alabama, USA, to lead wireless charger and media hubs for the automotive industry. And he also remained senior consultant to the state of New Jersey to secure 87 million grants, the spokesperson of Department of Homeland Security in 3GPP, an invited researcher in NASA Research Center, Cleveland, Ohio, and inventor for the Wells Fargo, USA. So I think without further ado, I would like to invite Professor Raziq to deliver his talk. So your mic is yours, Prof.
The topic of today's talk is driving forces behind rapid evolution and advancements in wireless communications, including 5G. But before I start my talk, I would like to thank the chairperson, Dr. Muhammad Helmi bin Abdul Wahab, ATRC Webinar series. I would also like to express my thanks to the head of ATRC, Dr. Zuhaira Binti Zainal Abedin, and I would also like to express my thanks to faculty and staff, UTM, ATRC, and all the participants. So the agenda of today's talk is that what are the forces behind rapid evolution of 1G to 5G. Under this topic, I would discuss a motivation number one, which is user radio resource efficiency, use of network resources efficiently, offer higher data rates and lower latencies, stronger security, more and more services, and then I will explain what are the services for providers' requirements for 5G, and finally, how 5G architecture is different from 4G. But before I start my talk, I would like to say that if you have any questions, please do not hesitate to interrupt me. You can ask the question right away, and I would be glad to answer any questions that you might have. So please do not hesitate to ask questions. And my way of delivering the lecture is that if you don't ask questions, then I will ask questions. So let's go to the 5G, a broadband technology that is being deployed in 2021 in most of the countries. And this 5G, the technical standard of 5G, is being prepared by 3GPP, which stands for Third Generation Partnership Project. So let's see what are the forces behind the rapid evolution from 1G to 5G. So in 1G, the phones were like this. It were bulky phones, and you have to carry the battery just like a backpack, and then you could make a call. And now it is 5G. So there is an evolutionary change from 1G to 5G. If you look at these dates, you would see that mobile phone generation changes every 10 years. In 1980, we had 1G. In 1990, we had 2G. In 2000, we had 3G. In 2010, we had 4G. And now in 2020, 2021, we have 5G. So every 10 years, the whole generation of cell phone changes. So what are the driving forces? What is the reason behind such a rapid change? So in order to discuss that, let's first see what are the major wishes of a customer. You are a cell phone customer, you are a cell phone user. So what is your major wish? For example, let me ask Arif, what do you think? What is the major wish of a customer? What is your major wish as a cell phone user?
To have faster.
Okay, very good. Yeah, very good. So, well, different customers have different wishes. I have listed 5 here. So I think the first wish, if you ask me, I would say lower bills. I don't want to pay a lot of bills for my telephone. So the first wish that I might have is lower bills. The second wish, as Arif said, higher data rates. People want higher and higher data rates. They want to download a movie in fraction of a second. They don't want to wait for minutes or hours or whatever. They just want the movie right away. And the third wish is more and more service. I want to see TV on my cell phone. I want to make phone calls on my cell phone. I want to use the internet on my cell phone. I want to use my cell phone for everything from camera to my health to my entertainment, you name it. Everything I want on my cell phone. More and more services on my cell phone. And the next big wish was lower latency. People cannot wait for loading. If they see this sign, they just start getting frustrated that when it is going to complete this. Low latency. Lower latency is another wish of a customer. And then finally, the quality of service. So these are the 5 major wishes of any user. Now, let me ask Ahmed, that what do you think? What are the business goals of a service provider? What do you think? What are the business goals of a service provider? What does he want? What is his goal? Any idea? Any idea, guys? What do you think? What are the business goals? What does he want? What does the service provider want? Let me ask is from Azim.
Profit.
Yes. Profit. Very good. Very good. Very good. So more and more revenue.
Thank you.
Very good. More and more revenue. Further, they want to reduce the cost. They want to reduce the cost and want to make more revenue. Then, what do you think? Where the cost comes from? What is the major cost buster? where the cost comes from. Anyone? Anyone? What do you think? Where this cost is coming from? Well, this cost comes from the capital cost. Means if I want to become a cell phone operator, I have to have the towers, I have to have the servers and routers and network and everything. So capital cost, I need some capital cost to have the infrastructure in place. Then there is the operation cost. I have my employees, I have to pay their salaries. I have to do the advertisements on TV. So I need to pay to TV. So operation cost. And the third one is spectrum cost. So guys, what do you think? What is the biggest cost from among these three? Capital cost, operation cost, spectrum cost. What do you think? What is the major? What is the biggest cost? Let me ask Aizan. Aizan, what do you think? I know you might not know, but just guess about from these three, what do you think? What is the biggest cost to the operator? Or anyone? Maybe Azmi? Okay, so if you, I think you are muted. So let me tell you, the biggest cost factor, the biggest one is the spectrum. The spectrum is the biggest cost of an operator. And what is the spectrum? The frequency. The operator has to use some sort of frequency, right? And this frequency is the biggest cost because it is just a license, just a permission to use the frequency. And it costs millions and billions of dollars. In United States, if I want to use, if I am a service provider, if I am a cell phone operator, I must get permission from FCC, Federal Communication Commission. And they would give me permission to use some frequency. But in order to give me that permission, they will charge me millions and billions of dollars. So that is a major cost. So the frequency spectrum is the biggest cost. Now how the person, how the operator, if he wants to achieve his business goal, what does he wish? What are his wishes? So his first wish is use the spectrum efficiently. Why use the spectrum efficiently? Because spectrum is the biggest cost. What is spectrum? The frequency that he wants to use. So this frequency is called spectrum, and he wants to use this spectrum efficiently. If he gets the permission to use only this much spectrum, he wants to use this much spectrum very, very efficiently. If he buys too much spectrum, of course, that is good, but then he has to pay a lot. So he wants to buy minimum spectrum, but wants to use it very efficiently. The second wish is that he wants to reduce the operation cost. And the third wish he has is to reduce the capital cost. So let's see these one by one. When I say use spectrum efficiently, what I mean that he wants to serve more and more users in a given spectrum. Means he wants to make more calls, more simultaneous calls in one cell. And the second wish is that he wants to send more bits in 1 hertz. Instead of sending 16 bits in one cycle, he thinks if I could send 24 bits in 1 cycle. So he wants to send more and more bits, means higher data rate, basically. And then he wants to reduce the cost. And how he can reduce the cost? Share the resources. And the third one is how he can reduce the capital cost, maybe using the less equipment. Here, there are 7 base stations to cover this area. His wish is that if I could use only 3 base stations to cover this area, because 1 base station costs him a lot of money. So he thinks that instead of having 7 base stations, that may cost me $7 million, I want to use 3 base stations. So he wants to use lesser and lesser base stations. So he wants to use less equipment. So the first one is he wants to use the spectrum efficiently. He wants to reduce the operation cost, and he wants to reduce the capital cost. Now, the question is how he can use the spectrum efficiently. And that is the driving force number 1. That is the motivation number 1, that how we can use the spectrum efficiently. How an operator can serve more users in a given spectrum. So let's see how an operator can use the spectrum or radio resources efficiently. The technologies that we had in the past were FDMA, frequency division multiple access, time division multiple access, code division multiple access, and now OFDMA, orthogonal frequency division multiple access. In 1G, that is the very, very beginning of the cell phone, it was in 1980. It was FDMA, frequency division multiple access. So let's assume this is my frequency band. I bought 200 kilohertz from our FCC, Federal Communication Commission. You might have Malaysia Federal Communication Commission or something like that, or maybe Telecom Authority of Malaysia or something like that. So you have to buy the spectrum first if you want to become an operator. So let's say you purchase 200 kilohertz spectrum. In those days, in FDMA, in one generation, first generation, one conversation needed 30 kilohertz. So if this man wants to make a call, he needs 30 kilohertz of that. So if I purchase 200 kilohertz, I can only serve 1, 2, 3, 4, 5, 6 users because I need a little bit of gap so that there is no interference. So 30 kilohertz for this, 30 kilohertz for this, 30, 30, 30. So I could accommodate only 6 users. That is the reason that in 1980, the telephone call was so expensive because only limited people could use the frequency at one time. So operator wanted to charge on per minute basis, right? So longer you make a call, longer the more you pay, because operator wants you to make your conversation short so that other people who are getting the busy tone at that time, they could be accommodated. So in 200 kilohertz, 6 people could only make a phone call. And that was in 1G or first G when we had frequency division. This frequency 200 is divided into 6 people. That is why we call frequency division. It is 30 for this, 30 for this, 30 for, and so on. Right? Now, if I could carry 6 calls only, my revenue would be very, very less. I can do only 6 people. I can have only 6 people talk to each other. So that was not a good idea. So there was a invention and technical effort behind this, that how we can increase the users, how we can increase more and more users in one cell. So what happened was the second G, 2G, was invented. 2G was GSM, and it was time division multiple access. So time division multiple access means earlier we had 6 users who were using the channel. Now we have again 6 spectrum divisions, but this one frequency, this one, 30 kilohertz, this 30 kilohertz was divided into 8 channels. This 3 kilohertz was divided in 8 channels. This was also divided in 8. So now this 30 kilohertz, instead of 1 person was using, now it would be used by 8 people. This 30 kilohertz, instead of being used by 1 person, would be used by 8 people. So in this way, we can have 48 people. But how can we do that? How can we have this 30 kilo used by 8? So it is called time division. So what they did was, they thought that, well, most of the time when people are on phone, maybe they do not talk a lot. What I mean by that is that if the other party is talking, I would be just listening. I will not be talking, right? Or in other words, let's say if I'm talking to my wife, right? She talks and talks and talks, and I normally say yes, 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 because I am a yes man to my wife. So I normally, I don't say a lot. So they said, well, instead of giving 3 kilohertz to Dr. Yaqub, give this 3 kilohertz to him just for a fraction of time, and then take it and give it to other, and then take it and give to the third person, and so on, in a round Robin Hood fashion. So my channel is taken from me and given to the other person, and to other person, and to other person, and then it comes back to me. And this way, the frequency that is assigned to me is divided into 8 people in a very rapid way. The channel is given to me for a fraction of a second, taken from me for a fraction of a second, and then given to other. So it happened in a very fast way, and I do not even notice that channel was taken away from me. So the time is divided. The frequency is this that I'm using, but the time is divided into 8 people, right? So it is given to me, then to next, and then comes back to me. But this happened at a very, very fast way. Just like a fan, when it runs, you don't see the blades, you see very fast motion. Exactly the same way it goes in a very fast way, and it takes my data, another person's data, another person, 4, 5, 6, 7, 8 people data go on one channel, and when it arrives on the destination, it is given back to those who the people are talking to. So it would be just like this, that one packet from me, another packet from the other guy, the third packet from this, and so on. So the data travel on one channel, but of different people. So the time is divided into different people. So the frequency of 30 kilohertz, 30 kilohertz, 30 kilohertz, 30, 30, 30 is now divided into different time slots. That is why we call time division. So first, just for the fraction of second given to him, and then to him, and then to him, and so on. So instead of 6 people using it, now 48 people are using the channel. So in 2G, that was very efficient. The same 200 kilohertz spectrum. Now that was used by 48 people. Now my revenue started increasing. And then I dropped the bill a little bit because I could make a lot of money. So I thought, okay, let me reduce the bill so that more and more people can join the network. But still, 48 was still not a good number. So the scientists and engineers, they kept their effort and they wanted to have more and more users. So they invented 3G technology, which is a CDMA phone. And this came in 2020. CDMA networks were available in 2020. So here, the technology was that instead of dividing the frequency or instead of dividing the time, issue the different codes to different people. So if a person A is using code 1, person 2 would be using code 3, person 3 would be using code 3, and so on. So they divided this frequency into different codes. Instead of different time, they divided into different codes. So each person was given a specific code. So that was code division multiple access. And that was the 3G network. And in this case, we could accommodate about 70 times 70 users in one cell. So of course, from 6 to 48, and then from 48 to 70, and that was even much better because now we could, now the operator could reduce even the bills a little bit less, right? So then the operator was still not happy. 70 people, well, I want to give the service to more and more people. So 4G was invented. And in 4G, as well as in 5G, they started using orthogonal frequency division multiple access. And orthogonal division multiple access means that the communication was divided into multiple carriers, into about 1,000 carriers. And what does it mean? In order to explain it in a simple words, let me give you the analogy of this tap. If I put a thumb on this tap, the water flow will stop. There would be no water coming out of this tap. But look at this shower. If I put my thumb, the water will still be pouring. Maybe just 1 or 2 or 3 streams will be blocked, but most of the streams will be coming. That makes the system more robust and make the data more noise vulnerable. It makes the data more stronger against the noise. So let me give you another example about that. So your voice, instead of sending on just one frequency, instead of sending on this frequency, they decided that they would send on 1,000 frequencies. So what does it really mean? So what it really means is the following. Let me give you an example. Let's say you want to move from one city to another city, and you put you get this truck, right? So you put all your household in this truck. But remember, is it better to put all your stuff in one truck, or is it better to have, let's say, 10 trucks and put your stuff a little bit in one, a little bit in another, a little bit in another, and so on? Of course, putting the stuff in one truck is economical. I have to pay to only one truck. But the problem with that is that if this truck meets an accident, then everything would be destroyed. You will not get anything in your second half. But if you hire 10 trucks and put a little bit stuff here, a little bit here, a little bit here, a little bit here, a little bit here, and a little bit here, of course, that would be little expensive. But if one truck meets an accident, you will still have 9 trucks available, right? So the loss would be minimal. If you hire 1,000 trucks, and if one truck meets an accident, maybe you would lose only just a little bit of your household, because your whole household luggage is divided into 1,000 trucks. So if one truck meets an accident, only small loss would happen. That is the philosophy between 1,000 carriers. That the voice, my voice, instead of sending on one frequency, it would be sent on 1,000 frequencies. So that if one frequency, one channel gets lost, still there are 999 channels which are still arriving to the receiver. That makes the sound robust. And because the sound is robust, now I can have more and more users. And in this case, I could have even 10,000 users. So that was number one motivation. That was number one driving force, that how can I increase my users? Because the spectrum is so expensive and I don't want to pay higher cost. And if I pay higher cost for the spectrum, I want to use it for more and more and more and more users. Then 1G was only accommodating 6 people. Second, 48. 3G was accommodating 70 people, and 5G about 1,000 people. Because the technology, the orthogonal frequency, where we divide the frequency into thousands of carriers, send on the channel, and even if one channel damages, destroys, disappear in the air, still we have 999 channels. Just like this truck example, that if one truck meets an accident, you are still safe because you have a lot of stuff divided into different trucks. So that is the idea behind OFDMA, and OFDMA is used in 4G as well as 5G. And these carriers are called orthogonal carriers. Now let's see what is the motivation number 2. And the motivation number 2 is using the network resources efficiently. And what do I mean? What I mean is that instead of using the circuit switching, let's use the packet switching. And before that, let me give you this example. I want to share the resources. So for example, instead of having one pole for one telecom operator, I can share the cost if only one operator builds this tower and several people install their antennas. So it is, for example, built by one operator. He built a tower and several Malaysian operators are putting their antennas, so the cost is shared. And the second way of sharing the resources is that do not use circuit switching, rather use packet switching. Now, what is circuit switching and what is packet switching, and how packet switching shares the resources? So let's see into this. It is very, very, very important thing. In 1G, 2G, 3G, there was circuit switching. The circuit switching was used in 1G, 2G, and 3G. Now it is becoming just a history. So what is circuit switching? In circuit switching, each telephone, I'm using the example of a landline phone just to explain. So in 1G or in circuit switching, each telephone was connected to the exchange. And I'm talking about the landline. Just to explain the concept, I'm using the example of landline. So what happened was that each phone was connected to a exchange or the switching center. If this man wants to make a call to this man, there needs to be a connection between this, and then this, and then here, and then they would talk to each other. And this was a physical wire connecting these two. And again, I'm giving the example of landline. So who would connect these wires? Who would connect these wires? Actually, there was an operator. And she used to connect the wire between these connections, and then this could talk to this one. That was a circuit switching because the switching was done by the operator. Later on, they made some improvement and they replaced this human being with the automatic switches. So these automatic switches were designed by the German company, and that was Siemens basically originally. So they came up with the idea of automatic switching. So whenever there is a word circuit switching, it means one phone is physically on a physical copper line is connected to another, and these connections are made either by the operator or by the switches, mechanical switches. Packet switching is different. In packet switching, there is no connections made. There are already connections there, and the packets travel from different routes. So for example, if this computer or this cell phone is sending a text message to this cell phone, or this cell phone is calling a voice call to this cell phone. So the packets would be for example, going through different routes to this. Well, this is a little difficult to understand what I want to explain. So let me give you an example that what do I mean by packet switching. So let's see the next slide to explain the packet switching using an example. Let's assume that this is me, right? And let's assume that I live in USA, and just for the sake of explanation, my wife lives in Malaysia, right? And I want to write a letter to her. So what I do is I use a unique technique, unique way of writing the letter. What I do is I take a piece of paper and write one word only, my. That's it. Just a whole piece of paper and write only one word, my. I put it in an envelope, right? Put a stamp, put my address, my wife's address in Malaysia, and take it to the mailbox and come back. When I dropped the letter, the mailman came and he saw that this letter is going to Kuala Lumpur, Malaysia. So he checked, he took it to the post office. So the post office people checked that, well, this letter is going to Kuala Lumpur, so how we can send it to Kuala Lumpur? Well, look at the schedule of flights. So they see, well, the next flight is from my city, which is Huntsville. From Huntsville, there is a flight to Washington, D.C. And then from Washington, D.C., there is a flight to New York. And from New York, there would be a flight to Singapore. And from Singapore, there is a flight to Kuala Lumpur. So the letter from my home will go to DC, New York, Singapore, and Kuala Lumpur, and then delivered to my wife. Then I came back and I write the second word, dear. The first letter was my, the second word is dear, my dear. And I do the same thing again, put in an envelope and write the address, my wife's address, stamp, drop it in the mailbox. The postman comes, he sees that it is going to Kuala Lumpur, he sees the flight schedule, and he sees, okay, next flight to Kuala Lumpur is from San Francisco. So from my airport, the Huntsville airport, it goes to San Francisco. And for example, from San Francisco, there is a connecting flight to Japan. And then from Japan, there is a connecting flight to Kuala Lumpur. So again, the letter goes from different airports and finally arrives at my wife's address. Then I come back and write wife. So first letter was mine. The second letter was dear. The third letter was wife. And I send it. Again, the mailman comes. He takes the letter and he says, oh, now the next flight is from Los Angeles. So he sends this to Los Angeles. From there, for example, the connecting flight is to for example, let's say China, and from China, it goes to Kuala Lumpur. Now, I keep doing this, and this is my letter. My dear wife, I love you. So 1, 2, 3, 3 letters. This is my 4th letter. This is my 5th letter. This is my 6th letter. I hate living in a dorm. So I'm writing one word in each letter. And each letter is going from a different route, different airports. I hate living in the dorm. It is difficult to adjust here. I wish if you, my cute, lovely friend, be with me now. So this is my letter, and I wrote only one word in each letter. So I use 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. I sent 30 letters, which went from different airports. And then my wife was receiving them, and she was putting them together, and she retrieved this message that, my dear wife, I love you and I hate living in it. So that is how the packets went from different airports, but finally came to my wife. And she arranged them, and first letter she received, then she received the second, then third and fourth, and now she got the message. That's how the packet switching is. But the problem is that what if the flights do not arrive in a timely manner? The flight that left earlier, maybe due to some technical fault, arrives late. So there is a possibility that my letter, they just get messed up. They do not arrive in the order I wanted to be. So if this happens, there is a problem that, well, the 3 letters arrive in a timely manner. In this case, this love packet got delayed and hate packet arrived early. So the message reads like, my dear wife, I hate you. I love living in a dorm with a cute, lovely friend. It is difficult to adjust with you now. I wish if you were. So the whole subject is changed now. This is the problem with packet switching. And if it happens, maybe my wife will come and she will divorce me because everything got messed up, right? So the packet switching has the benefit that I don't have to establish the circuit switching. The packet goes from different airports, from this place to this place, different airports are used. But the problem with this is that if the flight gets delayed and the other flight arrives earlier, then the whole thing would be messed up. So therefore, there is a concept of quality of service. And by the way, this packet switching is used in Skype, in WhatsApp, and in all internet-based communication. But the problem is that we need to solve this problem, and the solution is quality of service. So the solution is quality of service. Now, what is quality of service? Quality of service is that each packet that goes on the network, it would be given some priority. If it is a voice packet, give priority number 1. It should not be delayed. Otherwise, my message will be different. It may become I hate you instead of I love you. The second priority is given to the video stream. So those packets which are related to video, they are given the second priority. Means the routers, when they see that this packet belongs to a video, and this packet is voice, they send voice packet earlier and delay the video packet a little bit. And the third priority is given to the browsing. So if you are browsing an internet, even if it is delayed a little bit, that's fine. And the fourth priority is given to email. So when you send the email, the routers, when they see that these are email packets, well, the first priority should be the voice packet. So that is how the quality of service works, right? Now, the next driving force or the motivation was higher data rates and lower latencies. So guys, if you look at this GPRS, that was 115 kilobit per second. GPRS, 115 kilobit per second. It was very, 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 very slow network. And if you want to download this movie, it would take you 1 week, whole 1 week to download this movie. Then when this edge, which is 2.75, it is not yet 3G, it is in between 2G and 3G, then there was an edge network. The rate was 384 kilobit per second. And in this technology, it would take 3.5 days to download this movie. Well, this is better than this, but still 3.5 days, who will wait for that long? So therefore, 3G was invented. And this 3G, using 3G, you could download the movie in 1 day. Compared to 1 week, now you can download the movie in 1 week because the rate was 2 megabit per second. But again, the people were not happy. 1 day, whole 1 day waiting for a movie to download. Well, we don't want this 3G. We want 4G. And with 4G, 1 gigabit per second. So now this movie could be downloaded very fast. And then actually with 4G, this movie could be downloaded in 1 hour because the speed is 70 megabit per second. And then LTE advanced, 1 gigabit per second, and then 5G, which is 10 gigabit per second. And you can download movie in 1 second, less than 1 second. So that was the motivation. That's what people wanted. We want higher data rates because I cannot wait 1 week to download a movie. I want the movie to be downloaded in 1 second. So that is the second motivation or the second driving force behind the evolution from 1G to 5G, because people wanted higher and higher and higher data rates. And lower latency, as I said, you don't want to wait. You don't want the spinning circle to keep spinning. You want to download. You cannot wait. So the latency in case of 1G was 700 milliseconds. Very fast network, very, very less latency, very, very less delay. So if you want to download, it would not be spinning forever and ever. Your YouTube or whatever would be downloaded instantly. So that is higher data rate and lower latency, and that was another requirement or the other driving force or the motivation behind the rapid evolution, right? Now, the third one is the need for stronger security. The need for stronger security. And stronger security means that in 1G, there was no security at all. If you are talking, anyone else could listen by tuning his radio, his car radio, to that frequency, and he could listen to your conversation. You are talking on your cell phone, right? You think that only the other party is listening, but that was not the case in 1G. If I tune my radio, the car radio or whatever radio, to that frequency, I could hear your communication. That was not secure at all. Then in 2nd G and 3G, they encrypted the communication. So when I'm talking, my voice is encrypted and no one else can listen. Only the person to whom I'm talking, he will decrypt and he can understand. So my cell phone would be encrypting it and the other party's cell phone would be decrypting it. And moreover, the security in 2G and 3G was just one way security. What does it mean? Only the network could authenticate the user that yes, he is the right user, he has paid the bills, so it is good, he is good. Network allowed him to make a call because he has paid them. So there was security, one-way security. The network wants to authenticate the user that he is a legitimate user. And in case of 4G, it was a two-way security. Two-way security, what does it mean? Two-way security. I will explain this in my next slide. And in 5G, again, it is two-way and it is end-to-end security. So let's see what is two-way. Let's assume you are in this country, Zimbabwe, right? And you are at the border. You live right here at the border with Botswana. When you are making your phone call, this is your cell tower. So your cell tower should catch your signal and send the signal to the called party. But actually what happened was that this Botswana telecom operator, he was not honest. He increased the power of his cell tower. And when he increased the power, this cell phone got confused. This cell phone thought that, well, this is my home tower. So instead of talking to this, which is in his own country, he started talking to this one. And at the end of the month, this man received a roaming charge, roaming bill. And then he talked to his operator in Zimbabwe that I never went to Botswana. Why I have a roaming charge? And he said, well, you are probably in Botswana, that's what. And then they came to know that, well, this operator was not honest. He increased the power and he deceived this user and he attracted, he got the call by unfair means, and then he charged the roaming charges. So that was not fair. That is why there was a need for two-way security. The network authenticates the user and the user authenticates the network that I am talking to the right network, and the network wants to authenticate that I'm talking to the right user. So two-way security, right? Then more and more services, because earlier it was just voice in 2001, then there was SMS, multimedia, webmail, and then you wanted TV and multimedia services and music download and file transfer. So more and more services. In 5G, you have Internet of Things kind of services as well. So with the passage of time, from 2000 to 2021, the data rate kept increasing and you kept providing more and more services because users wanted more and more services. And I know I have 4 more minutes. 5G requirements, according to the operators, they wanted the higher data rates, up to 10 gigabit per second. They wanted more capacity, 36 terabyte per month per user. So the network should be capable to provide 36 terabytes to one user in 1 month. That kind of capacity is needed by the users because of this YouTube and Facebook and all kind of uploading and downloading, having cameras and WhatsApp and so on. Yeah, they wanted more and more data. They want to send more and more data. So for one user, for 1 month, 36 terabytes. And spectrum, higher frequencies, and spectrum flexibility. What does it really mean? I can explain, but I just want to go to the next slide. So these are some of the requirements. And finally, what I want to say is that this is the 5G reference architecture, where there are different user devices. There are 5G base station, 4G base stations, Wi-Fi, fixed, and then there is a user plane function, and basically what I mean by this is basically it is for example, if this is your base station, this is your base station controller kind of functionality, right? And this is the core network where you have AMF, SMF, PCF, AF, NSSF, AUSF, UDM, and 5G control plane. This is all called 5G control plane. What is NSSF? So all these abbreviations are defined here. The difference between user plane and the control plane is that when I say user plane, only the user traffic is mentioned here. Means if I am making a phone call, my words are user plane traffic. The control plane is, well, the signal is low, make it a little higher. Well, the signal is dropping down, and move it to the next tower, hand it over to the next tower, and so on. These kinds of signaling related information was for the control plane. Guys, it is almost 1 hour. I still have few more slides. So let me ask Dr. Helmy that what is the plan? Would you, well, I have few more slides, and
yes, Prof. Yeah,
yes.
you can finish your slide, no problem.
Oh, okay. So let me take a little bit time on this. This is the architecture for the 5G. There are a lot of functionalities, a lot of entities. They perform a lot of functions. I don't go into that detail right now, but I would like to discuss the simplified version. Whatever I say here, it is the simplified version of that, where the 5G user equipment is connecting to the cell tower, and then there is an aggregator. From aggregator, it goes to the core network, and core network is also connected with the billing entities, and then it could be connected to the external network for cloud computing and virtualization, global content provider, and nanotechnology. So this is our radio network, this is core network, and this is external network. Some of the functionalities, some of the hardware is in the cloud these days. So instead of having a base station controller in my network, it would be in the cloud. So that kind of concept is there. And the biggest thing about this 5G is that the network could be sliced. If this is our network, if this is operator's network, that could be sliced. For example, part of this network can be used for mobile services only. Mobile broadband means communication, entertainment, internet, and so on. Part of this network can be used by machine-to-machine communication, right? For example, retail, shipping, manufacturing, where the machines are talking to machines. Smart grid, electric vehicles, all included in this. Then the network can be sliced into a third slice, which is for mission critical IoT services. For example, those services which require reliability and low latency, for example, autonomous vehicles, or maybe medical services, or maybe power system, telecom services, critical infrastructure. And then the fourth slice could be for other applications, for example, virtual reality, artificial intelligence. So this one network would be divided into several slices. This slice is specific for mobile communication, and it has its own optimized resources, connectivity, speed, capacity for mobile services. Those things which are related to machine communication, that would use a different slice of this network. So slicing of the network is one of the attractive features of this 5G. And then what are the 5G enabling technology? I would just mention few, but maybe I would ask Dr. Helmi to arrange next webinar and we can discuss these slides in a little bit more detail. Well, the slide that I just rushed very quickly, we can go over these slides in a more detail. So what are the 5G enabling technology? Millimeter wave, small cells, massive MIMO, beam forming, full duplex, and network virtualization. These are the 6 enabling technology. And what do these words really mean? This needs some time to explain that what is a millimeter wave? Why do we call it a millimeter wave? What is the benefit of using millimeter wave? Then why small cell? And then what is massive MIMO? MIMO stands for multiple input, multiple output, but then now we are talking about massive MIMO. So what does it really mean? What it is going to bring to 5G? How it would be beneficial for 5G? And then beamforming. What is the concept behind beamforming? What do we really mean by beam? So beam means making the signal targeted in one direction. But again, it needs a little bit time to explain that what is beamforming. Duplex and network virtualization. So these are 5G enabling technologies, and these needs to be explained in more detail. And for that, I need 1 more hour to explain. So with this, I end my talk, and thank you very much for your attention and your time. I really appreciate that. And if you have any questions, please do not hesitate. You can ask me, or you can send your question in the chat message. So please go ahead.
Okay, thank you very much for very informative talk about the evolution of wireless communication, including 5G. So
you're welcome.
I would like to ask the audience, is there any question? You can ask the Professor Raziq, or you can put in the chat box the question, and I will read the question to them. Any question? Maybe 1 or 2 questions. So if there is no question, I think this is very interesting talk. So maybe there will be another session as you wish, Prof. We will arrange for another session for another 5G in details. We will discuss later. So since there is no question, I would like to say thank you to all the audience to come to this webinar series. And then We see you in the next session. And then after this session, we have a short discussion with the Professor Raziq for the short discussion with the head of the ATRC only. So you can wait for the bit. So thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
There is